Myself, Dr. Divya, Assistant Professor at Department of Chemistry, Institute of Aeronautical Engineering. So today we will discuss the next session in the water technology, hardness of water and its types, and then estimation of hardness of water and the troubles in the boilers when we go for the practical applications. So here are the topics: hardness of water, types of hardness of water, then units of hardness that has to be used for the expression of hardness, then determination of hardness of water, then boiler troubles. So what are the troubles we will be facing if we use hard water for the boiler? So what is the hardness of water? So when the water does not give lather, so we know that whenever soap is in the water, it gives some lather. This is the lather. So when it doesn't give a lather, then the water is called hard water. So it contains, why it is? Because it contains calcium and magnesium salts. So high concentrations of calcium and magnesium salts. So this is the reason why the soap doesn't give lather. So the degree of hardness is generally measured in parts per million, also called ppm in abbreviated form, then grains per gallon. So these are some of the expressions we use for the degree of hardness. Then soap consists of long fatty acids. So soaps are generally made of fatty acids such as oleic, palmitic and stearic acids. So they have long chains of these fatty acids. So what happens? These calcium and magnesium ions in +2 state react with the sodium salts of these long chain fatty acids, so that are present in the soap and form insoluble scums. So this is nothing but insoluble scums of calcium and magnesium. That is why they will not form lather. So depending on the concentration of these ions present in the water, the hardness can be defined. So as if it is 0, then it is low harder, it is the soft water, and when as the hardness increases, the concentration also increases. The concentration increases, the hardness of the water increases due to high concentrations of these calcium and magnesium salts. So we will see what are the different types of hardnesses. Why are we calling types? So there are two types: temporary hardness or carbonate hardness, and permanent hardness or non-carbonate hardness. So we are saying that we have some cations or the metals in the form of their salts. So it can be either in the carbonate forms or non-carbonate forms. So depending on their removal, if they can be removed easily, then it is called temporary hardness, that is due to presence of magnesium and calcium carbonates in water. So these carbonates can be removed easily from the water through boiling. So therefore they are under temporary hardness, and this hardness can be removed by boiling. So what is permanent hardness? It is due to soluble salts of magnesium and calcium present in the form of chlorides and sulfides. So chlorides and sulfides doesn't dissolve easily, so they cannot be removed. They cannot be removed from the water, and therefore they cause permanent hardness to the water. So this hardness cannot be removed by boiling, simple boiling, therefore called permanent hardness. So if we see some vessels or some tap, this is a tap that we use. So tap outlet. So if we use hard water, this is how it will get accumulated with the salts. And if you use soft water, this is how it will be clean and you can be used for longer time. So what are the expressions that we use for the calcium carbonate? It is expressed in the form of calcium carbonate for the hardness. So the concentration of hardness as well as non-hardness constituting ions are usually expressed in the equivalent amount of calcium carbonate. So why we are choosing only calcium carbonate? Why we have to express in the form of calcium carbonate? Because of its molecular weight 100 or the equivalent weight 50, and it is the most insoluble salt that can be precipitated in water treatment. So that is the most form of the hardness that is present in the water. So therefore we are expressing in calcium carbonate form. So the hardness causing salt in terms of calcium carbonate is generally expressed as mass of hardness causing substance into chemical equivalent of calcium carbonate multiplied by molecular weight of calcium carbonate divided chemical equivalent or molecular weight of hardness causing substance. So this is the expression that we use for the hardness estimation. So this is the unrearrangement. Mass of hardness causing substances into 50, that is the chemical equivalent of calcium carbonate, and molecular weight, that is substituted to the chemical equivalent or molecular weight of hardness causing substance. So this is how we generally use equivalence of calcium carbonate for expressing hardness. So these are the units that are used. Number of parts of equivalence of calcium carbonate hardness causing salt present in 1 million part. So we are saying parts per million. So parts present per 1 million of water is nothing but ppm. So this is one of the form of expression that is used for the hardness. Then milligram per meter liter. So it is the number of milligrams of equivalent of calcium carbonate per liter of hard water. So if you see 1 milligram per liter means 1 milligram of equivalent of calcium carbonate present in liter of this hard water. Liter of hard water. This is the water. This is the salt or the impurities. Then other one is the degree Clark. So it is the number of grains of equivalence of calcium carbonate causing salt in 70,000 parts of water. So when we take it for 1 million, it is ppm. When we take it for 70,000 parts of water, then it is called degree Clark. So the other expression or the units is the degree French. So it is the number of parts of calcium carbonate equivalent hardness causing substance in 10 to the power 5 parts in water. So this is the other form of expression. So if you see, this is the interconversion of units. So wherever we see the units converting, we have to remember if it is 1 million ppm, 70,000 degree Clark, and if it is 10 power 5 parts, then it is degree French. So this is how we have to remember and use it for further calculations and estimation of hardness. So how do we really have to remove? Do we have to use it hard water for the applications? No, we have to remove it. So there are some methods that can be used. So for temporary hardness, we can use simple boiling. So boiling that we use in a regular process can be applied for removing temporary hardness. So upon boiling, what happens? The soluble salts of bicarbonates of calcium are converted to calcium carbonate, which are insoluble. So these calcium bicarbonate is soluble, so it is converted to insoluble salts of calcium bicarbonate to carbonate, so that can be removed through filtering or gets precipitated. So after filtration, what we get is the soft water. See, if you see the boiling, after boiling, if we filter this water, after filtering, it will be soft. So the water will be soft and all the calcium salts will be lost as a precipitate. So this is kept in the form of equation. So if we see bicarbonate is converted to calcium carbonate and water and evolving carbon dioxide. Other method is a Clark's method, where calcium hydroxide is a Clark's reagent that is used for conversion. So it removes the hardness of water by converting bicarbonates to carbonates. So the logic is same. However, we are using a reagent for faster removal. So the calcium hydroxide is added to the water that is containing calcium bicarbonates. So these bicarbonates can be converted to carbonates and can be removed through filtration. So that can be removed through filtration, both calcium and magnesium salts. So these are simple methods that can be used to remove temporary hardness of water. Then determination of hardness of water. So there is a simple method for determining the hardness of water during our daily applications or any water treatment or for potable water, drinking water, any water. There is simple experiment that is used for determining the hardness of water. So that is the titration with EDTA. Ethylene diamine tetraacetic acid is a complex that is used for chelating agent that is used in the titration to obtain the hardness. So this is a complexometric titration. Complexometric titration. Why we are saying complexometric titration? Because it is forming a complex with the metal ions. So it is in the form of sodium salt which eats the anion, and this forms complex with calcium and magnesium 2+ ions. So this is the EDTA. This is the EDTA. So the sodium salt, generally this is sodium. So the sodium salt of this EDTA forms an anion leaving this hydrogen. So these will form a complex with the calcium and magnesium ions. Calcium and magnesium ions. So that is how it is called as complexometric method. So to determine the equivalence point, so how do we really understand whether the hardness can be estimated through this method? So we are using some indicators like colored indicators can be helped in will favor in understanding the endpoint or the equivalence point of this reaction. So Erythrome black tea EBT, an alcoholic solution of blue dye is employed. So this can be used for conversion of color from one color to other color. Any color the dye can be changed depending on the pH. So that will help in understanding the formation of complex. So it forms an unstable wine red color complex. So whenever we add, as soon as we add an addition of EBTA to water, it forms a wine red colored solution. So it is because of formation of complex with calcium and magnesium ions. So this indicator is effective at pH 10. So this this indicator works at pH 10. Therefore, we adjust the pH adjustment to be done using buffer like ammonium hydroxide and ammonium chloride mixture. So at this pH, it forms a complex. So that is why it is giving wine red colored solution. So after titration, it turns to blue color. So this is how it undergoes the reaction. So during the course of titration against EDTA, so once the EDTA is added, so from the burette, EDTA is added from the burette. So what happens? EDTA combines with metal ions and form stable complex metal EDTA. Metal EDTA. This is nothing but metal EDTA complex. Metal EDTA complex. And releasing free indicator. What is this? Erythrome black tea indicator. So this indicator will again combine with other metal ions that are present. So these metal ions will be again reacted with the free EBT and retains the red wine color of the solution. So this is how the reaction takes place, and depending on the end point, we use the calculations to understand the hardness of that particular water. So what are the advantages and disadvantages of this method? So if you see the advantages, it is very simple and accurate. To an extent, it is very accurate with a simple method. So we only use a burette and a pipette and a conical flask and an indicator. So very easy to use. So it is cost effective and it is also very quick and time efficient. Time efficient is nothing but it takes less time. So when compared to other gravimetric analysis, if we want to do some gravimetric analysis like precipitating, it takes some time. But however, the titration method is time efficient. And the disadvantages are Like there might be some human errors. For example, if you forget to add indicator, what happens? There is no reaction. We think that reaction is not going on. So the human errors are it is related to human errors that has to be avoided at utmost care. We have to perform the titrations so as to get good results. Otherwise, it is a big disadvantage for this method. And EDTA grabs all the metal ions present in the water. So the EDTA, which is capable of forming complex with metal ions, it can form with all the ions, not just calcium or magnesium. So that is other disadvantage, and this gives us a value that not truly the concentration of calcium 2 plus ions. So if it forms complex with other ions like iron or other cobalt, then it is understanding that it is not just because of concentration of calcium. And this causes an experimental error of 1%. So as we see, the other metal ions are very low in water. So therefore, even if it is 1% of experimental error, it is acceptable. So this is why it is most widely used method till date. So, what are the troubles that we will be facing? Boiler troubles during our applications in engineering. So, generally, feed water is a water that undergoes purification or preheating and is then supplied to boilers for hot water and steam production. So for in the manufacturing industries, we use steam for various purposes. So for the production of this steam, we use feed water that will be helping in producing the steam. So this feed water is nothing but the normal water we are just feeding to the equipment. So that has to be less, it should have less hardness. Otherwise, what happens? We'll just check it out. This is typically found in thermal power plants where it is stored and conditioned in tanks known as boiler feed water. So these boiler feed waters are different. Like if we have, there are different types of boilers. If it is low pressure, medium pressure, or high pressure, depending on that, there could be variation in the hardness. So if it is low pressure, 40 to 80 is the acceptable limit. So that is a maximum limit that is accepted for the boilers. So if it is medium, it should have less hardness. So it should be having in between like 10 to 40 ppm. And if it is producing high pressure, then it is less than 3 ppm. It should contain less than 3 ppm of hardness of water. So the hardness should be less than 0.2 ppm, and the caustic alkalinity, it can have the composition like caustic alkalinity due to OH minus ions, excess of OH minus ions, the soda alkalinity due to sodium carbonate, and should be less than like 1 ppm. So these are some of the prerequisites for any boilers for functioning. So we will see what are the troubles that are going on if we use hard water for the industrial applications. So in boilers, what happens? Water evaporates continuously, and the concentration of dissolved salts, the salts already present in water, the concentration will increase. So upon with increase in temperature, there is an increase in the salts concentration. So when the dissolved salts concentration increases and reaches a saturation point, so when it reaches a saturation point, they are thrown out of water in the form of precipitates. So once it is reaching some saturation point, it is precipitating. So precipitating on the inner walls of, where does it precipitate? In the boiler itself. So inner walls of the boiler. So this is how it forms troubles to the boiler. If the precipitation takes place in the form of loose and slimy precipitate, so if the precipitation is like this, loose and slimy, then it is called sludge. And if the precipitation forms hard adhering crust or coating on the inner walls, then it is scale. So these are scales. These are scales. It is hard and it is hard enough for the coating, so it cannot be removed so easily. This is slimy and loose form. So this is sludge and scales. So we will see in detail how these are affecting. So the formation of sludge, how does it form? It is formed at comparatively colder portions of the boiler and collects where the flow of water is low or its base. So it generally forms sludge generally forms in the cold areas of the boilers. So because of flow rate of water is low. And sludges are formed by substances which have greater solubility in hot water than in cold water. So like example, magnesium carbonate, magnesium chloride, calcium chloride, magnesium sulfate. These are some of the sludge forming salts that affect the boil. So, what are the disadvantages of sludges? For example, if there is a formation of huge sludge in the boiler, what happens? These are bad conductors of heat and results in wastage of heat and fuel. So, there is some obstruction in the boiler for releasing the steam. So, what happens there? We have to heat it for more time and using more fuel. So, that is how it gets wasted. And sludges entrapped in the scales get deposited as scales cause loss of efficiency of boilers. So, for example, if we have a tube like this, if there is a formation of scale, so the efficiency decreases. There is some experimental design that is used for forming this tube. So, the inlet and outlet efficiency effects. Then what happens? Excessive sludge formation leads to settling of sludge in slow circulation. Areas such as pipe connections leading to choking or blocking of pipes. For example, what I said before is like, for example, if this pipe is getting scaled up, then what happens? Scaling up, then what happens? It gets blocked slowly. The pore will reduce. It will reduce the size of that pore. So ultimately leading to blockage. So how we have to prevent? So by using soft water which is free from dissolved salts like magnesium carbonate or magnesium chloride or calcium chloride and magnesium sulfate. So all these has to be avoided. So how can we do? Like blowdown operation can prevent this sludge formation. So we will see how it can be further improved to obtain good operation of these boilers. So the next one is the formation of scales. So this is the formation of scales which is very hard, that is formed in that pipe. So due to decomposition, how does it happen? Like decomposition of calcium bicarbonate at high temperature and pressures present in boiler, and it forms calcium carbonate insoluble salt and settles as precipitate in the boiler. So this is the conversion from bicarbonate to carbonate. So, if, for example, we have seen in the boiling technique, where in the removal of temporary hardness, wherein bicarbonates are converted to carbonates that can be removed as precipitate, like through filtration. But what happens in the boilers is, if the same reaction takes place in boilers, the bicarbonates converted to carbonates, this gets accumulated in the boiler itself. So that will really affect the boiler operation. So the formation of calcium carbonate scale is soft, and the main cause of scale formation in lower boiling. This is the main cause of scale formation in the low pressure boilers. So in high pressure boilers, what happens? Calcium carbonate is soluble. Calcium carbonate is soluble due to high pressure and temperature. So the solubility of calcium sulfate in water decreases with rise in temperature. So in the case of sulfates, its solubility decreases even with rise in temperature. That is, like calcium carbonate is soluble in cold water but completely insoluble in superheated water. So what happens then? It gets precipitated as hard scale on the heated portions of this boiler and causes the damage to the high pressure boilers. So the presence of sulfates is really very dangerous in the operation of high pressure boilers. So how does the chemical reaction that takes place in the formation of the scales, like hydrolysis of magnesium salts. So the magnesium salts dissolve, undergo hydrolysis at high temperatures, forming magnesium hydroxide precipitate and forms a soft type of scale. Magnesium hydroxide, which is a soft type of scale. So this is the reaction on hydrolysis. It forms magnesium hydroxide and evolves HCl. So, in presence of silica, silica is another small impurities that shall be present in the water. So that what happens in small quantities deposits as calcium silicate. So, if we have calcium already in water, and if there is silica, it forms calcium silicate or magnesium silicate. So these deposits stick very firmly and it's very difficult. Silicates are very difficult to be removed, and the important source of this silica is generally sand filter that is in the water. So important source of silica in water is a sand filter. So the scales, what are the disadvantages of scales? For example, if there are the formation of scales like these in the boilers, what happens? Wastage of fuel, like as we discussed before, like there will be wastage of fuel and money, like invested money, and then heat transfer, because it is a bad conductor of heat. The heat transfer from wall of boiler to water is reduced or decreased. Like heat transfer is generally decreased because there is a formation of scales in the particular boiler. And to get steady supply of heat over, so in order to get high heat, steady or continuous supply of heat, we have to heat it rigorously. So this keeps on overheating the boiler, so hence loss of heat and fuel. Then lowering of boiler safety. So due to formation of the scales, what happens? There is safety issues that will be taking place. So due to scale formation, we have to heat the boiler to high temperatures, and this can weaken the material that is used, like boiler material that is used for formation, like manufacturing. So this distortion of these boiler tubes, for example, this tube, like they got two holes. These got distorted due to unnecessary heating, that is due to scales. So that is really unsafe to bear the pressure of that steam. So there is some there can be there will be chances of bursting. So then decrease in efficiency due to scales deposits, the choking of boiler is observed. So if there is scales formation, it will be there could be a backward reaction or the backflash, so that will cause choking of the boiler. So how do we have to remove? If the scale is really soft, it can be removed by scraping by a piece of wood or wire, and if it is brittle, by giving thermal shocks by heating to a high temperature and sudden cooling. So this is how we can remove the scales if it is brittle in state. But if it is hard and adherent, what you have to do, it is removed by washing with 5 to 10% of HCl and calcium sulfate can be removed by washing with EDTA. So if we wash the boiler with these solutions, it can be removed due to chemical reaction that takes place and dissolve the scales. Prevention, the important thing is, like, we have to prevent. Prevention is better. So there are some different treatments that are used for prevention: internal treatment and the external treatment. Internal treatment is the softening of water by adding proper chemical to the boiler. So for example, if we already keep using hot water to the boiler, there should be some treatment that has to be done during its operation. So we can use some chemicals that could be added to the boiler water during its operation. Or the external treatment, before feeding the water to the boiler, we have to soften the water. So we will see the treatments in detail. So the other one is the caustic embrittlement. It is a type of boiler corrosion. So the parts of the boiler get corroded due to high alkaline water that is used for the boiler. So during softening process by soda lime, free sodium carbonate is usually present in small portions. So even after softening, during softening also, there will be some sodium carbonate that is left over in the water. So what happens? This sodium carbonate will react with water and forms sodium hydroxide. So nothing but caustic, nothing but caustic, and evolve carbon dioxide. So this causes some embrittlement to the parts of that oil. So this sodium hydroxide contained water flows into minute hair cracks always present in the inner side of the boiler by capillary action. So even if there is a minute crack in the boiler tube, then it penetrates into that hairline crack and causes a big damage to the boiler. So the water evaporates and dissolved, caustic soda concentration increases. So this is how the embrittlement takes place. So this caustic soda attacks the surrounding area. The chemical reaction, what we takes place is the caustic soda attacks the surrounding area, thereby dissolving iron of this boiler as sodium ferrite. So if we see this, if this is the crack, for example, so it will be diffused into the crack. So this causes embrittlement. So this iron will form sodium ferrite. So ultimately leading to failure. So the iron surrounded by dilute NaOH or sodium hydroxide becomes cathodic site. So this is the cathodic site. It has dilute NaOH. While the iron is in contact with concentrated NaOH, so this is the dilute. Concentrated NaOH, then it forms anodic part which will be consequently dissolved or corroded. So it is really forming an electrochemical cell leading to leading to corrosion leading to corrosion. So this is how the part will get damaged. This is how the part will get damaged. So how do we have to prevent? By adding sodium phosphate as a softening reagent instead of sodium bicarbonate. And another one is adding tannin or lignin to boiler water, since these block the hair fractures. So these organic materials will block any, if there is any crack or hairline cracks, then they can be used for these blocking these cracks, so that will prevent the infiltration or immersion of the sodium hydroxide. So this is how it can be avoided. Or the other one is the sodium sulfate that can be added to the boiler water. This sodium sulfate, what does it do? So it has to be kept in the ratio of 1:1:2:1 or 3:1 in boilers working respectively at pressure of 10, 20 or 30. So if it is 10, if it is working at a pressure of 10, then it should use 1:1 ratio. So this is how it can be used for avoiding the caustic embrittlement. So how do we really adjust these ratios? By taking the sodium sulfate concentration to the sodium hydroxide concentration. So for example, this is the sodium hydroxide concentration forming during the caustic enrichment. Then the respective ratio has to be adjusted with sodium sulfate. And what are the disadvantages? If it is really damaging the parts of boilers, then the cracking or weakening of the boiler takes place. Ultimately, failure of this boiler ultimately causes the failure of boiler. So the next one is the priming and foaming. So the other problem is the priming and foaming. It is a phenomenon of carrying out droplets of water with steam. So the steam has to continuously go. But what happens if there are droplets of water? if there is water along with steam, then it is called priming. So due to rapid and boiling of water inside the boiler, the water particles mix up with the steam and pass out from the boiler. So this water will go along with the steam. This process is called wet steam generating, and is caused by several reasons. Like one of the reason is the hardness of water, and the other one is the foaming. It is a phenomenon of formation of foam or bubbles on the surface of water. For example, we are using water. This is the water we are using in the boiler. So if this is a formation of this foam or bubbles, nothing but foaming, then it also causes damage inside the boiler with the result of carrying foam along with steam. So it all goes along with the steam. Even if it is a water droplet or foaming, it goes along with the steam to the applicated part, like protection. So the foaming and priming are collectively known as carryover. Like if there is some impurity going along with steam, it is nothing but carryover. It is carrying some impurities to the steam. So how can we prevent? The priming can be prevented by proper boiler design, like avoiding impurities, maintaining proper water level, maintain the concentration of solids in boiler water at low level. Concentrations is nothing but the salts, impurities. And for foaming, anti-foaming agents like synthetic polyamides or castor oil, then coagulants like aluminum hydroxide. These are some of the commercial preventing methods that can be used to avoid foaming and priming in the boilers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.